right, guys, so don't forget the mock exam is due tomorrow. If you have it today, of course, I'll take it, but I should be getting those red folders from you guys tomorrow. We're going to have our last test on Friday. So remember, the mock exam is a test, and then this 313 to 315 test is on Friday. These are 2 tests, so we're done with testing after Friday. Okay, we'll have homework checks and some quizzes, but that's it. Your polar project is due Friday. Of course, I'll take it sooner. Friday's a test day, so you might want to turn it in earlier so it's not like crazy for you. And homework check on Thursday. So we're going to do a test review Wednesday, Thursday. 2-day test review for a 1-day test. So it's a lot of time to get the test review taken care of and questions answered. And I will have copies of the test review ready tomorrow for you if you want it early. Okay. Okay. Definitely using our calculators today. So make sure you've got that nearby. And we should be able to finish everything in class, no problem. Okay, so let's pay attention. It's kind of exciting. This is our last section of the year. Last section of the year. It's kind of bittersweet. Like, I can't believe when I looked at when I started this course at the beginning of the year and I got all of Jean Adams, the lady that made all this, I got the packets and I realized the job ahead of me that I had to teach all of that stuff. I remember thinking it's pretty overwhelming. And here we are. We're at the end. We have 2 days left. Tomorrow's the last new material. So exciting. Then we'll review lots and lots for the last month. Okay. So consider, well, let me read to you for a second. Just like any other function we've studied, polar functions can be analyzed for key features and characteristics. So in this final lesson, we want to describe intervals of increase, decrease, extrema, distance from the origin, and average rates of change of r with respect to theta. So just like we have with every type of graph, we've talked about like mins and maxes, the zeros, which are the x-intercepts. We've talked about slopes or rate of change when there's a curve. And so we'll get more into that part tomorrow. Today we're really talking about max values and zeros. So let me show you what I'm talking about. So if we consider this curve right here, we should be able to look at it without the graph and know that it's a circle. Okay, we should recognize that equation as a circle at this point. And sine is positive going up, and so we go out 5 to, this is 5, and we make our circle. Okay, we're also going to put it on our graph in a second, or in our graphing calculator. Also notice the interval here. It's not from 0 to 2 pi, it's only 0 to pi. So interval is like your x-axis, your polar axis. In this case, it's our thetas, okay? So pick up your calculator, and let's make sure, we'll clear the mode first, clear the RAM, sorry. So clear your RAM. So second plus 712, and then let's go to mode and change to polar, okay? So to polar, right there. Now that it's highlighted on polar, I can go to the y equals button, which will now be r equals, okay? So I'm going to teach you some new things about the calculator. They're going to be helpful, but you need to kind of learn them from me as it can be a little confusing, okay? So 5 sine theta. Everyone knows how to type that in. You can graph it. You can see the circle. We've talked about the different zooms. Zoom trig is number 7. Someone else said they like zoom 0. You can really see up close and personal what type of curve it is with that. I also like zoom square. It shows it really more as a circle. It changes your rectangular screen to fit as if it were a square. Say it again. Yeah, I don't like this calculator on here. I mean, I like it, but so sorry. Second plus 2 mode. It doesn't show up very well. Okay, so anyway, playing with the different zooms to whatever makes you happy. Also, we use the table all the time, right? So if we go to second table, you might notice that your thetas are counting by 1, 0, 1, 2, 3, 4, 5. Well, that's not very helpful for us because when we are in polar form, we're using unit circle angles, right? I wish, this is what my dream would be, it's not possible, but I wish my theta column could actually say 0, pi over 6, pi over 4. It could give me my standard angles. It doesn't, but we can get pretty close to it, okay? So what we're going to do is we're going to go to table set. So second table set. And notice we've been here before, so let me remind you, we're starting at 0. That's fine. We want our table to start at 0, which in this case would be 0 pi. But we don't want to count by ones. What I can do is change this to count by pi over 6. Let me tell you why we're going to use pi over 6. Pi over 6 has all the multiples of the unit circle except for the denominators of 4. So if I count by pi over 6, my first angle will be 0, because I told it to start there. And then it'll go pi over 6. And then if the next pi over 6, so 2 pi over 6, 2 pi over 6 is pi over 3. Then 3 of these, so the third one after 0, would be simplified down to this. So multiples of pi over 6 simplify really nicely to all of your denominators of 6, 3, and your quadrantals, including your denominators of 2, because it's just multiples of those simplified. The only angles we don't hit when we change to pi over 6 is all of our denominators of 4. That's not included in there. So if we needed those, and I'll explain in a second when we would know that, we would change our change in table to pi over 4. Okay, so now go back to your table now that we changed that, and you'll see lots of yucky decimals. Well, these decimals, our calculators are great, but they don't do everything for us. And one of the things it's not doing for us is putting our theta in terms of pi, meaning pi is in the numerator like we are used to seeing it. This is multiplied the pi in. So let me go to my main screen. Like if I did pi over 6, pi over 6, if you wanted to write it, it's up to you. You don't really need to. But pi over 6 is 0.52. Pi over 3 is, and I'm not rounding correctly, these are just so I can look at them real quick. And you can keep on going. Pi over 2, let me just do this one last one. And it keeps going. So now when I go back to my table, and you start to recognize them the more you work with them, but I'm also going to show you another way. But so my 0.52 is pi over 6. My 1.04 is pi over 3, and so on, okay? But if you already know, if you understand what I just said, that we're counting all of the angles, this is just going around the unit circle, skipping the denominators of 4. So the first one is 0 pi, then pi over 6, pi over 3, pi over 2. Then we're in quadrant 2. 2 pi over 3, thank you. Skip the denominator 4. Then we're at 5 pi over 6, and then pi. Okay? So you can know that order to kind of find where you are in the unit circle, or you can go to your other screen and do some division to figure out which one the decimal equivalent is. Okay? So that's a drawback, but it's also going to help us answer a bunch of questions. Like, oh wait, we have one more thing we have to change. Remember we talked about the interval is from 0 to pi? That's our window. So we're going to change our window. Notice it says theta min and theta max. This is saying from 0 to 2 pi. That's what it defaults to. That's 3.14 times 2. That's what that is. We just want it to go to pi. So I'm just going to type second pi right over it, and that changes my interval. Okay? So now when I go back to my table, so this next question, I can either look at the table or look at the picture. What is the maximum distance from the pole? Like, where does the maximum occur? What is the furthest radius we go out to? What's the biggest R we're going to use in this whole picture? What number? Okay, look at your table if you can't tell. What's the biggest R value that we use? 5. It's the biggest one. And that makes sense. This is the point that's the furthest away from here. It's the maximum point. It's the highest or furthest away from the origin, the max. Think about in a parabola where the max is or the min is the highest or lowest point. Same idea here. This happens at pi over 2. So you could make an ordered pair out of it, 5 pi over 2. That is your maximum. Okay? This next one is about zeros. What are your zeros? It's a little bit different. So for what values of theta, so our answer is going to be theta equals something, where f of theta equals 0. That's code for where is r 0, at what angles. Like where are my x values 0, at what y values. But here it's r. Now, if we were not using our calculator, we would have to kind of plug values in, but you might be able to kind of narrow it down because this is 0 and, well, let me not say that. You could just plug values in. Okay, you could plug in, I would plug in 0 and pi. Those would be the two that I would plug in because of where the 0 is and where the points are. But looking at your table, you can see my radius is 0 at 0, and my r is 0 at what? What's the other one? Pi, right? We don't need to get a calculator out to know what angle that is. 3.14 is pi. So that's the two places from 0 to pi. Now, there's tons more. This circle goes on forever and ever and ever, around and around and around, coterminal, over and over and over. So there's lots of zeros in there elsewhere, but we're only concerned about from 0 to pi. Okay? All right, let's look at the next question. Describe the behavior as theta approaches this maximum from the left and from the right. So let's set up the answer. Let's set up how we're going to write this. So we're practicing here now, going into review time, getting ready for the exam, how we answer things in like complete sentences. You know, not just say it goes up, gets bigger, increases. Let's put a whole sentence. So as theta approaches pi over 2, why pi over 2? Because that's where the maximum is, from the right. And we'll have to do this again as theta approaches pi over 2 from the left. Okay? What's happening? F of theta, which is code for r, or you could have written r, what is happening? So let's look at the graph. So as I approach, so we always start at 0, 0. That's where we start graphing all these points. As I approach pi over 2 from the right, that would be going along the curve, watch my pen, going in this direction. What's happening to my r values? They're increasing. You can tell it from the picture, perhaps, but you should also be able to look at your table. Oh, I forgot I'm using this one. You should be able to tell from your table. From 0 to pi over 2, and pi over 2 is 1.57. That's half of pi. Your r values are increasing. They're getting bigger. Okay? Okay. Now, on the other side, as theta approaches pi over 2 from the left, so starting here and going up, are we increasing or decreasing? We're increasing as well. Okay? And you can tell that from your table as well, but just make sure you look at it in reverse, because we're starting at the bottom, at pi, because that's what this angle is. This is 0, pi, and then we're going this way. So 0, 2.5, all the way up to 1.5, we're getting bigger. So we're going this way, okay? All right, consider the value of the radius of the curve. Is there an interval where the radius is negative? Okay, so on the interval that they're having us use, are there any negative radii? No. Nope. No. All values of r are greater than or equal to 0 on the interval of 0 to pi. Now, if you keep scrolling, you go all the way to 2 pi, there are negatives. Remember, all that does is shoot them back through the origin, and it would still make the same graph, okay? But in this interval, there are no negatives. All right, so let's talk about this table. Let's do from 0 to pi over 2. Some of this is a repeat. The first two are repeat questions. We're just going to talk about them again. And then the third one is what we're going to go into a lot deeper tomorrow. So the question is, okay, let's just talk about from 0 to pi over 2. So we're talking about this right here, from 0 to pi over 2. What's happening? Is R positive or negative? Positive, right? They're all positive. We just talked about that. Is R increasing or decreasing? We already did that, right? We said it was increasing. Now, is the distance from the pole increasing or decreasing? So as I start here and I go towards pi over 2, am I getting further away or closer to the pole? I'm getting further away, right? So is the distance increasing or decreasing? Increasing, right? It's kind of weird. We've talked about how in other parts of this course, and just in math, not just in this course, they use that word increasing and decreasing to mean different things at different times, and that can be confusing. Oh, here's another one. Like how far the distance is. Is it increasing or decreasing? Let's do the same thing from pi over 2 to pi. So look at my pen. From pi over 2 to pi. That's different from what we did right here, which was from the left, like this. This is saying from pi over 2 to pi, which is right here. Are the R's positive or negative? Positive, right? They're all positive. Remember, we said all values of R are greater than or equal to 0, which is code for positive. Are the values increasing or decreasing? So now we're going in the other direction. This is 5, right? 0, 5. And the numbers are going to get smaller and smaller until we get down here. This ordered pair, remember, is 5 pi over 2. This ordered pair is 0 pi. Confusing, right? You almost want to say 0, 0, but it's not. So going from here to here, from 5 to 0, we are decreasing. Yep. It is 3 pi over 2 is further down. Let me see. What is 3 pi over 2? Let me try this. I don't know if you guys heard his question. His question was 3 pi over 2. So 3 pi over 2 is 4.7. So if we look at our table, see, it's negative 5. So his question was, why isn't this point 0, 3 pi over 2? Which is a great question. Why isn't it? Well, at 3 pi over 2, and you don't need a table for this, and let me explain that in a second as well, but at 3 pi over 2, which is 4.7, our R is negative 5. So down here, 5 circles, shoot, you'd end up back up here again at the top, okay? Or, you can plug in sine of 3 pi over 2. 3 pi over 2, sine value would be negative 1. So 5 times negative 1 is negative 5. So either way, right? We need to be able to use the calculator and, of course, be able to plug in by hand as well. So we're going to practice more of that tomorrow. Last question. Is the distance R from the pole increasing or decreasing? So as I go, here is the distance increasing or decreasing? Decreasing, right? We're getting closer. All right, and we're going to talk more about that table tomorrow, so I'll reference that tomorrow. That's not in the homework today. Okay, one more of these. Let's break down one more. Let's do a harder graph. Circles are pretty simple. Let's do the hardest type, which is a rose curve. So we know that this is a rose curve. Sorry, page 180. We know this is a rose curve because of that n value. It makes a multiple angle, okay? So because of that 3, just because of that 3, we know this is called a rose curve. And I'm going to take it a little bit further with, since this is odd, it's that many petals, and petal length of R equals 4. Okay? So if I weren't allowed to use a calculator, I'd make a table of values and start plugging in, but we're using our graphing calculators today, so let's go ahead and do that. Let's change our R equals to this new graph. Notice the interval is the same. The interval's the same, so we don't have to change any of that. And let's see what the graph looks like. Okay, so here's my graph. So I'm pretty confident I know where this petal goes. I have a petal on the positive cosine axis, like this, right? And like we talked about last week, we are pretty, I think we could all make a very educated guess, assumption, that this petal in quadrant 2 and this petal in quadrant 3 are at our denominators of what? Denominators of what? What's the denominator? 3. These are the angles up by the origin. Another way up by the y-axis and down by the y-axis. Something else you could do is go to your table. So wherever we go out to 4 or negative 4, we're going to have a petal. And so if you went through these, you would see we're at, so where my cursor is, that's pi over 2. Okay, that's at the top. This next one is 5 pi over 6. So let's go ahead and put those in. So we're going to have one there and down here. Okay, for a sketch of the graph. Now, remember that our interval was only 0 to pi. So how do we have a point down here? Well, really, this point right here is negative 4 pi over 6. It's the petal that would have been here, but since it was a negative, it went here. So that's what this angle is called. I mean, technically, it's also 5 pi over 6. Those are coterminal, right? They're the same at the same place. There's two ways of naming that. But we wouldn't name that one because 7 pi over 6. Sorry, that's 7 pi over 6. I wouldn't put 7 pi over 6 as any point if it was asking for like the ordered pairs, because 7 pi over 6 is not in our interval. But pi over 6 is with a negative radius, okay? So anywhere in our table where we have a positive or a negative 4, we're going to have a petal, okay? So one thing that we didn't, I remember I made the executive decision not to teach you guys about symmetry, and I still am not going to go into it, but just in case a question comes up, sometimes it's really, really simple, like this one. It says to describe the symmetry. This red line is the x-axis, but it's also called the polar axis, if you remember. And this has polar symmetry, they call it, because if you folded your graph on that polar axis, all the points on the top half would match up with all, they're mirror images of each other. See, right? These two in the same exact spot. You split that petal into equal parts. So I decided to throw that in there since it was there. What's our max value? The absolute value of R. What's the biggest R value we're going to use? Come on, guys. What is it? 4. Everyone stops at that question. I feel like no one's understanding it. We don't go any higher than 4. Ever. We don't go any higher than 4. But especially not between 0 and pi. So I can fill my screen. What's kind of nice is 0 to pi is exactly the size of the screen. You can see the biggest value I use for any of my R's is 4. And it's absolute value. We don't care if it's positive or negative. It's not a negative, really. It's about a direction that you go in polar equations. Okay, where does it occur? Well, it can occur more than one place, right? On the circle, it was just that one spot, really. But here, we have it happening at 0. Or 0 pi, you could write 0 or 0 pi. It happens at 1.04. Remember what 1.04 is? You don't have to memorize it. You can use your calculator, but also remember 0 pi over 6 pi over 3. Then again at 5 pi over 3, 4 pi over 3, 2 pi over 3. One of them. Quadrant 1, quadrant 2. Okay? That's our 3 petals. Why did I put a 6 here? Why didn't anybody tell me I'm wrong? And I'm recording this. Ugh, I'm so sorry. I can sometimes tell when I make a mistake because Jordan, your foot starts moving. Like you want to interrupt me, but you don't want to interrupt me. I can tell. So when Jordan's foot starts moving, I'm like, what do I do? What do I do? See how in tune you guys I am? Yeah. No, I'm so sorry. No. Guys, the angles that are closest to the y-axis are your denominators of 3. These are your denominators of 6. I don't know. I got distracted somehow. But anyway. So what question do you guys have for me? Something? So this is 0, right? Pi over 3 is here, but it had a negative radius, so it shot it down here. But you still call it. And then this one right here is 4, 2 pi over 3. Right, we wouldn't use 5 pi over 6 because we're not in that, we're only going out 0 to pi. So if this had, so for example, if this had 0 to 2 pi, for example, we would have more, we would keep listing them. We would have pi over 6, or pi over 3, we would have this angle, we'd have this angle and shoot through the radius. So there'd be more, but we're only looking at 0 pi. So anywhere your radius is 4 or negative 4, those are where we have maximums, okay? And lastly, again, same question. This is from the homework. This is what you're going to be doing in the homework, and this is what you're going to be doing in the homework. You're going to sketch the graph, and you can use your calculator or not, and then you're going to identify the maximum of where it happens. And then this is, where is R0? Where are the thetas where R is 0? Okay, on the interval only that we're talking about. I mean, it's pretty simple if you're using a calculator, right? You just have to, you guys just need to be able to name these angles better than me. So 0, then pi over 6 has a 0 at it. And then 1.5, that's pi over 2. You start to get to know them the more you work with them. And sometimes I can just like say, all right, so I'm at the angle right before pi, right? If I know that's pi, the one right before it would be a denominator of 6 as well. So that's all my R's of 0. How would I do this without a calculator? Yuck, plug and chug. Okay. One last thing before I give you the homework. When you, remember there was a graph, I forgot which one, but I think it was a petal, a rose curve that went out into the middle of all, and we would say, I think it's pi over 4. When you're using your calculator, so if any of these petals went out into the middle and I wanted to check it, I would have to go into my table and change the table there to be counting by pi over 4. And that would give me, okay, if I'm going out to 4, I go back to my table and my radii are 4 at all of my denominators are 4, then I know that it's right in the middle, okay? So using pi over 6 works for all of the angles except for your denominators of 4, okay? So that's the only one you would have to come in here and change. Okay, I hope I didn't confuse you too much with my unit circle mess-ups. Probably did. Let's go to the homework. I'll start with you very, very short. WWE. Uh-huh. I used to watch the show, the Bella. No? The Bella twins, you know? No, they're on now. We'll talk about it later. Okay. Okay. All right. So what we're going to do here, guys, is I'm going to do number 1 the way I want you to do them all. You're going to sketch the graph. Okay. Just a sketch. And you're going to answer questions, but we're going to use this interval. So we'll have to change that on our calculator. So let's start by identifying that this is a circle. Okay. And it's a negative cosine. So it's going to go to the left 3. 1, 2, 3. You can draw the circles if you want, but we're just sketching, so just a rough graph is fine. Okay, there's the graph. Let's put it in our calculator. Negative 3 cosine theta. There she is. But I do want to change, I want to change my window. Because remember, we've been working with 0 to pi. Now we're going out to 2 pi. So that's in your window. Change your theta max to 2 pi. Theta max to 2 pi. Okay. what I want to know is, what is our max? What's our max value? 3. Yep. Where does that happen? Well, look at your table. Anywhere you see a 3 or a -3, a max happens. So it happens at 0. Does that make sense? Yeah, because it's got a -3. So we did go out 3 circles to the right, and then we shot across the origin and landed right there. So it happens at 0. And then, of course, it also happens at pi. And then also, r is 0 at what thetas? So you list them. So 1.57, that's pi over 2. That only goes up to pi, so we just get some more on our screen here. Let's go all the way out to 2 pi, which is 6.28. So we have another one at, what is 4.7? I don't know. Do I know? If you don't, sometimes this is a hint. If we have a 0 at pi over 2, it's probably 3 pi over 2. But you could count, where you are in the quadrants, or go into your other screen and do 3 pi divided by 2, just to be sure. Okay, 3 pi over 2 is 4.7. You don't need to memorize them. Okay, so that's what you're going to do for 3, 4, 5, and 6. Mock exam due tomorrow. Mock exam. We will. Yeah, we're going to be grading them in class together. Yes, yes. Oops, where's the key? Sorry, let me pick you up. Oh no, I'm like off my game today. I wasn't before. Oh, okay. I took so few days off that I don't even recognize. Thank you. Look at number 2. Are you glad I made you skip? I let you skip it.